Hello everyone, today we're going to look at the first half of logarithms. So a logarithm is the inverse of an exponential. So we start with an exponential, y equals b to the x, and then we solve for the variable x. We say that x equals log base b of y. So I want to make sure everyone's saying it correctly. It's log base b of y. Remember that y in parentheses is function notation. It's not log base b times y. It's log base b is the function name of y, like f of x, g of t. Log base b of y. Make sure that it's base b. The b is a subscript. It is below the word log. Okay. Also, it's really important to keep in mind that everything we knew about exponentials is also true about logs. So in particular, my base has to be positive and not 1. Right? Remember, if b is 1, we just have 1 to the x, which isn't an exponential, it's just y equals 1. So remember that b has to be positive. And my y also has to be positive. Or if I take a positive number and I raise it to an exponent, it's always positive. So what's inside my log, my y, has to be positive, and my base also has to be positive. So that's something to keep in mind later on. So what we're going to do is we're just going to convert from one form to the other. So you're either going to be given an exponential and convert it to a log, or you'll be given a log and you want to convert it to an exponential. So 6 squared equals 36. That is an exponential. We have an exponent, which in this case is 2, and we're going to change it to a log. So the key to remembering this is that the base is the base is the base. Doesn't matter if it's talking about a logarithm or an exponential, the base is the same. Our b is the base of the exponent, and our b is the base of the logarithm. So the base of this guy is my 6. So I know right away it's log base 6 of something equals something. Now remember, these are inverses of each other. It can't equal the same thing. A letter or a variable can't be a log and an exponential. So since my exponent equals 36, that cannot be what equals my logarithm. So I know that the 36 has to go inside of it. And then the 2, the exponent, is what my log equals. My log is an exponent. Okay, so the log is the exponent, the base is the base is the base. And if you can remember those two things, you'll be able to convert from one to the other pretty easily. So log base 6 of 36 equals 2. How about if we start with a log? Log base a of c equals d. So again, I always start with what is the base. So the base for my log is a. So I'm going to have a to some power equals something. I know that right away. And then again, I can think of the next step in two ways. Whatever my exponential equals cannot be what my log equals. So since my log equaled d, my exponent cannot also equal d. My exponential, sorry. So what goes in the equal sign has to be the other piece, which is the c. The log is the exponent. The log is d. D is the exponent. So d goes in the exponent. So a to the d equals c. X to the 4th equals 64. So again, I'm going to start with what is my base, which is x. My log equals the exponent, which is 4. And then what the exponential equals goes inside the log, where you're kind of switching the two around. How about 5 equals log base 3 of 243? So again, I start with what is the base. The base is 3. The log equals the exponent. The log equals 5. 5 is the exponent. And it equals the only other number that's left. whenever you have all numbers and no variables, you can always check it. Is 3 to the 5th 243? Yes. If you have variables, you can't really check it. So 9 equals 5 to the w. It's an exponential. The base is 5. So I'm going to start with log base 5. My log equals the exponent. The exponent is w. So 9 must go inside the log. Log base 5 of 9 equals w. And for the last one, log base s of r equals t. The base is s. The log equals the exponent. And then there's only one other place for the r to go. How do we find the value of something like log base 2 of 5? So if it's something that we can easily find with the exponents, then that's not too bad. If I had something like log base 2 of 16, well, for now I'll call it x because that's what I'm looking for. And if I change it to an exponential, it would become this, 2 to the x equals 16, and I know that x is 4. So log base 2 of 16 equals 4. However, if what's inside of here can't easily be written as a power of my base, we're kind of at a loss. If I wanted to rewrite this, I have log base 2 of 5 equals x, then 2 to the x equals 5. Again, just off of that, I don't know the answer. I do know a little bit about it though. I know that 2 squared is 4, and that 2 cubed is 8. So I know that x is somewhere between 2 and 3. And 5 is a lot closer to 4 than it was to 8. So it's going to be just a little bit bigger than 2. But that's as far as I can get without trying to do anything with my calculator. So I know it should be something a little bigger than 2. But how do I find it? Again, I need a calculator. And what we're going to do is we're going to use what's called the change of base formula. So most calculators have something in their calculator that looks like log of x, and they have something that looks like ln x. So log x is log base 10, and ln is log base e. So remember we talked about e in the exponential section. So e comes up a lot, and it's Euler's number, 2.7 something something something, it's irrational. But ln is the natural log, but then for some reason the letters are switched, so probably, in Greek or Latin it's backwards. So ln is the natural log, log base e. Log x with no base is understood to be base 10 because that's what we use in daily life, right? We have ones, tens, hundreds, thousands, 10,000s. Those are all base 10. Okay, so we have those in our calculators, and then we're going to use those in what's called the change of base formula to do things like log base 2. So the change of base formula is log base b of a equals either ln of a over ln of b or log of a over log of b. And in reality, I could choose any base that I want, but I'm going to choose one of the bases that my calculator has. So one of the nice things about the way that we write log base b of a is that b is already below the a, and that's how we remember that that's the one in the denominator. Okay? Always make sure that whenever you're using this change of base formula, your answer makes sense. So again, we want to do log base 2 of 5. I know the answer better be a little more than 2. If I do the change of base formula backwards, my answer will not be a little more than 2. So if I wanted log base 2 of 5, I would do either ln of 5 over ln of 2 or log of 5 over log of 2. It doesn't matter which one you do, you just have to make sure you're doing the same base in the numerator and denominator. So I want you guys to do these out and make sure you're getting the same answers. Be really careful if you're going to plug this in all at once. Make sure you're putting these guys in parentheses. You don't want to be doing log of 5 divided by log of 2. Okay, so really pay attention to order of operations here. And hopefully you'll be getting 2.3219 blah 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 blah. And it is, like we said, a little more than 2. Okay, and again, if we had done it backwards, we would have got 0.431, and that doesn't make sense. 2 to the 0.431 is nowhere near 5. Okay, so always go back and check, does it make sense? So using your calculator, find the following. Log base 2 of 16, we kind of already talked about that, but again, using the change of base formula, you should be still getting 4. Log base 5 of 625. So again, that's ln of 625 over ln of 5, or log of 625 over log of 5. And you should be getting 3. Again, if we change this back to an exponential, the base is 5, the exponent is 3. Is that true? Yes. Okay, so always make sure your answer makes sense. Log base 3 of 20. So again, that's ln of 20 over ln of 3, or log of 20 over log of 3. And hopefully we're getting 2.73. So then I go back and I rewrite it as an exponent to see if it makes sense. Well, I know that 3 squared is 9, and I know 3 cubed is 27. So it makes sense that my exponent is somewhere between 2 and 3, and 20 is a lot closer to 27 than it is to 9, so it makes sense that my answer is closer to 3 than to 2. You can also put this into your calculator. It won't be exact because we did round a little, but you can always check it that way too. How about log base 6 of 125? So log of 125 over log of 6. Again, please make sure you're putting parentheses there. And you should be getting 2.69. And again, 6 squared is 36, and 6 cubed is 216. So 125 is between those two, so I know my answer is 2 point something. It's closer to 216 than it is to 36, so my answer is closer to 3 than it is to 2. Log base 24 of 24. So notice if I'm plugging that into my calculator, I'm getting something divided by itself. I don't care what ln of 24 is. When I divide it by itself, I know that it's 1. Also, if I change it to an exponential, this is telling me 24 to the first is 24, which hopefully we all know is true. How about ln of 400? So this you don't need the change of base formula for. It's already in one of the bases we have. So don't try to do ln of 400 over ln of e, or log of 400 over log of e. It's just ln of 400. And you should be getting 5.99. Log base 5 of 500,000. So hopefully we know this is going to be a sort of higher number, right? I need to multiply 5 quite a few times to get to 500,000. So let's plug it into our calculators. Log of 500,000 divided by log of 5, or ln of 500,000 divided by ln of 5, and we get 6.72. Don't try to do something where I've seen people do before, which is the following. They try to cancel the 5s, and they'll call this ln of 100,000, right? That is not how you simplify logs. You cannot simplify things inside of logs that way. We're going to talk about how to simplify logs in a minute, but don't forget order of operations. I have to take the ln's before I can divide. Okay. And then log of 30. So again, there's no base. It's base 10. I have that in my calculator. I do not need the change of base formula. And I get 1.48. Again, I can check to make sure that makes sense. 10 to the 1 is 10. 10 squared is 100. 30 is between those two. It's closer to 10 than it is 100. So my answer is 1 point something, closer to 1 than it is to 2. So now we're going to look at properties of logs. So the first property is how to either expand or constrict our logs depending on which direction you're looking at. Typically we go from more logs to less logs, but sometimes we want to expand them. But what this is saying is that if I have a log of a product, I can split it up to be a sum of logs. Now these properties of logs are coming directly from the properties of exponentials. So this is coming from the fact that if I have x to the a times x to the b, it's x to the a plus b. Multiplication becomes addition. Multiplication becomes addition. Okay? Similarly, we have division, which goes to subtraction. Again, this is the same thing as x to the n over x to the m becomes x to the n minus m. If I have division inside of a log, it becomes subtraction outside of the log. And it's backwards from exponentials. I had division outside of the exponentials, became subtraction inside. It's the opposite with logs. Log base b of x to the p equals p times log base b of x. So if I've got an exponential inside of my log, it becomes multiplication outside of it. And again, that's because of this property of exponentials. X to the n to the m equals x to the n times m. And then log base b of b equals 1. We saw this in the previous slide with the 24s. Log base b of b, if I want to use the change of base formula, I get this, which is just 1, or the fact that b to the 1 equals b. So as long as my base and what's inside my log are the same, it's going to be 1. If I want log base b of 1, that is always 0, again, no matter what the base is, and that's because b to the 0 is always 1, which we talked about back in the exponential section. So let's expand each logarithm into several logarithms, leaving no exponents. Log base 2 of 6x. So I look at what's inside my logarithm and I ask myself, is it a product, a quotient, or a power? So those are the three things that I can expand. So 6x is a power, so I'm going to use that first rule and break it up using addition. So that becomes log base 2 of 6 plus log base 2 of x. Log base 3 of 4x cubed. So here I have two operations. I have a multiplication and I have an exponent. You have to be careful because when you are separating them, you have to make sure you're separating them correctly. I have to get rid of the multiplication first because that 3, that exponent 3, is not being applied to the 4. So I'm going to separate it with the multiplication first. And then I'm going to take care of this exponent. So I'm going to use the fact that an exponent comes out as multiplication. Okay. But again, you have to be careful with the order of operations. It's, again, kind of backwards. If I was plugging something into 4x cubed, I would do the power first and then multiplication. But when I'm breaking it apart, I have to go backwards. I have to break apart the multiplication and then break apart the exponent. Log base 4 of 7x over y squared. So again, I've got multiplication with the 7x, I've got division with the 7x divided by y squared, and I've got a power. So I've got all three operations in here. And again, you just have to be careful that you're separating them at the correct times. So what I do first is I'm going to separate the 7x from the y squared. So again, I'm doing order of operations backwards. So I'm going to do log base 4 of 7x minus log base 4 of y squared. Then I'm going to separate this one using addition, really into those two. And I'm going to bring the 2 out from here. So I have log base 4 of 7 plus log base 4 of x minus 2 log base 4 of y. You can always check these by plugging in values for x and y and using your calculator. I wouldn't suggest 1 or 0, so try like plugging in a 2 or a 4 or a 10, something like that. ln of 3x plus 6. So notice I've got addition inside of here. We do not have a rule that separates logs across addition inside the log. So this is not ln of 3x plus minus multiplication, division, anything with ln of 6. However, if I look at 3x plus 6, you will notice that it has a GCF. So I can change my sum into a product by factoring, and now I have a product, which means I can separate it with addition. But it's going to separate with 3 and x plus 2. So that's going to be the best I can do, ln of 3 plus ln of x plus 2. And now that I've done all of them, I realize they're all labeled a, which really doesn't make sense, but it doesn't affect it at all. But those should be a, b, c, and d. But let's go into the one that's actually more important, which is simplifying your expressions into a single logarithm. Log of 5 plus 3 log of x. So whenever we're going from multiple logs to a single log, we always want to first look for exponentials, which come in this case as coefficients. Before we can do the addition and the subtraction, becoming multiplication and division, we have to get rid of the coefficients. So the very first thing we have to do is write 3 log of x as x cubed. So we're going to have log of 5 plus log of x cubed. Then we're going to use the addition and change it into multiplication. So we end up with log of 5x cubed. Log base 6 of x squared plus 3 log base 6 of 2x. Again, just like before, I need to bring in the 3 first. And also apparently these are all labeled a again. Please just ignore that. So here I know it's tempting to call this log base 6 of 2x cubed, but don't forget that 2 is also being cubed. So 2 cubed is 8, and then x cubed. So don't forget that whole thing, all of that 2x is being cubed. Now I'm going to do addition, so I'm going to multiply, and I have 8x cubed times x squared. I'm going to add those exponents and get 8x to the 5th inside my log. Log base 9 of 32x cubed minus log base 9 of 16x to the 4th. So I've got no coefficients out front to deal with. I just have subtraction, which becomes division. So I've got log base 9 of 32x cubed over 16x to the 4th. Always, always make sure you simplify. 32 goes into 16 twice. X cubed divided by x to the 4th leaves me with an x in the denominator. So I have log base 9 of 2 over x. If you want, you can write this as log base 9 of 2x to the negative 1. It's the same thing, so either way works. And then for our last one, log base b of 3 plus 2 log base b of x minus log base b of 9. So again, I see a coefficient. I have to do that first. So log base b of 3 plus log base b of x squared minus log base b of 9. So now I've got addition and subtraction. So I'm going to put those together. Log base b, 3 times x squared, because those are the two I'm adding, dividing by 9 because that's the one I'm subtracting, and again I'm going to simplify that. 3 over 9 is 1 over 3. So I have log base b of x squared over 3. Okay, so make sure that you read through the book and try out some of the homework problems. Also, make sure you watch part 2, where we'll be solving logarithmic and exponential equations. Thanks, and let me know if you have any questions. Bye.